Hi guys, so today we are going to basically do part one of solving systems of equations notes. We are going to do two methods today, and then tomorrow night's notes part two will be the other two methods. So first of all, what is a system of equations? A system of equations is two or more equations that are related to each other. That didn't turn out very well. Let's try that again. Are related to each other. Where's my O? And we're going to find the place where they cross, which is what we do when we solve a solution to a system of equations. So what is the solution to a system of equations? It's the place on the graph where two lines intersect. And if we are solving it algebraically, it's where the two functions represented are equal to each other, particularly when there's a story involved and we're trying to say, for example, if, on what day would Miguel and Matt both have the same amount of money? We're looking for the day and the amount of money that they would have on that day. So ways to find this point of intersection, we can find it by graphing, which we're going to learn about today. We can find it using what's called the equal values method, sometimes. And we can find it using substitution. And we can find it using elimination. And your goal in this unit is to basically have all four of these things in your toolbox, your math toolbox, and be able to look at a situation or a set of equations, that are given to you and determine which would be the most efficient way. All of these systems of equations can be solved using these four methods, but there's always an easiest or best way to solve them. So what if I'm given a story? Well, stories can be translated into equations. So most stories are going to be able to be translated into y equals mx plus b, or standard form, which is ax plus by equals c equations, and then you follow the exact same steps that you're about to learn about. So graphing to solve a system of equations. So we're going to solve by graphing. So general form, equations can be written in any linear form. For our purposes, there are nonlinear systems of equations that you may see in Math 2, or definitely will see in Math 2. Most common forms, of course, are y equals mx plus b, and our standard form, which is ax plus by equals c. And then that point slope form that we learned about, which is y minus y1 equals mx minus x1. So your process for this is step one, graph both lines on the same set of graph axes and locate the x, y point where they cross. So here's an example. Here we have standard form, and that's where I use what's called the cover up and divide method. So if I cover up the x, then I have 2y equals 12, which means y equals 6. So on the y-axis, I plot a point at the 6. And then if I instead go back and use the cancel out the y or cover up the y, I get negative 6x equals 12. Divide by negative 6, x equals negative 2. So I have a negative 2 right there. Now, I want to use a ruler to draw this as efficiently as possible. So let's see if I can't get a straight line here. so that I can find where they cross. If you are drawing your line all wonky, then you may not find the correct point of intersection. So let's graph this one, which is y equals mx plus b. So I'm going to plot this first. My -9 is down here. And this means I'm going to go down 3 and over 4. I can't do that on here, but if I go down and over, it's going to end up down here somewhere. So I'm going to actually go up 3 and over 4 to make this point right here. So if I draw my line to extend right there, now I can pretty easily see where these 2 points cross, or these 2 lines, excuse me. It's right there. So my solution is, let's see, -4, -6, and done. Okay, so here's example number 2, a story example that we're going to solve by graphing. Now, you're going to see other stories that you're going to solve using algebraic methods that you're going to learn about in tomorrow's notes. But for today, we're just going to do this one by graphing and show how to write the story. So first thing you want to do is read through the entire thing. You can underline important information, but I would read through this at least twice. So on the school that JD goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school has sold senior citizen tickets and student tickets, those are important information, for a total of 190. So on the second day of school, let's see if I can change color here. I guess I can't. We'll try that. Okay, so the school took in on the second day senior tickets, student tickets, and they took in 160. That was my total. Yep, that didn't come out so good. So we're going to basically write 2 equations here. We're going to write a day 1 and a day 2, because those are the 2 things that it's talking about in the story. So day 1, we have 10 senior citizen tickets. Day 2, we have 5 senior citizen tickets. So let's say that X is the senior price. So we're going to have 10X and a 5X. Now on day 1, we sold 11 student tickets. And day 2, we sold 12 student tickets. So let's call Y student. So we're going to go plus 11Y and plus 12Y. And then we have a total of $190, so equals 190. And a total of 160 over here, so equals 160. So now we're going to graph each of these. And let's see if I can find a good color to do the graph for this one. Use purple. So day 1, I'm going to graph in purple. And I'm going to use the cover up and divide method here also. So if I cover up the y, I'm going to get 10x equals 190, which means x equals 19. And then if I cover up the y, if I cover up the x, I'm going to get 11y equals 190. Actually, I have to pull my calculator out for this one. Let's do 190 divided by 11, and that's going to be 17.27. Now, we're talking about people here, and y is students, so we're going to actually cross that off and just use the 17 and the 19. So I'm going to actually go ahead and figure out what my x and y should be for the second equation here, just because I need to know how to scale my axis. So this one right here, we'll do orange. So I have 5x equals 160. Let's divide that. 160 divided by 5 is 32. Glad that I am doing this first, or I probably would have scaled it only to the 19 that I needed the first time. And then 12y equals 160. So y is going to equal 160 divided by 12 is 13.3, repeating, but we're going to cross that off and just keep the 13. So we've got a 32, 13, and a 19, and a 17. So my x needs to go to 32, and my y maximum is 17. So I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marks on either direction. So in order to get to 32 using 10 marks, I would have to go by 3s. And that would go a little bit off the graph still, but let's go ahead and do that. So this is going to go 3, 6, 9, 12, 15, 18, 21, 24, and 27, and this would be 30, and 33 is really going to be right here. And I just didn't have enough room to write all of that in. So then on the y-axis, my maximum is 17, and I have 10, so I could go by 2s right there, which I think makes sense. You always want to go by the smallest that you can in order to kind of zoom in on your graph. It makes it easier to see things. 10, 12, 14, 16, 18, here's 20. Okay, so let's go ahead and plot these points. So purple first here is going to be x equals 19. That's going to probably be, let's see, that's 18, so probably around right here. And then y is 17, which is going to be right here in the middle. And let's connect those. And then we've got our orange graph here, which is day 2. Has an x equal to 32, which is going to be right about right here, and a y of 13, which is going to be, let's see, right here. So let's go ahead and connect those and see if we can find the point where these cross. So this point of intersection is not so easy to see. This is where we may want to revisit this question maybe tomorrow when we've learned about how to solve these algebraically and see if we can't find a better answer or a more accurate answer. But here is my solution. So we have, let's see, right here is probably about, I'm guessing an 8. And then if we go over, I'm going to say that's probably meant to be on the 10, and maybe my graph was not perfect. So what this would be is 8 seniors, 8 senior tickets, and 10 student tickets would be my answer for this. Wordy questions need a wordy answer. So the 8, 10 wouldn't quite be correct. Okay, so now we're going to dip into the first algebraic method called the equal values method. This is actually a subset of substitution that you're going to learn about tomorrow. It's just a little bit easier method of substitution. So we typically follow equal values method when both equations are in y equals mx plus b, or one or both equations can easily be converted into y equals mx plus b. So if you see something that looks like this, equal values is a good idea. So process, step 1, if necessary, convert one or both equations into y equals mx plus b. Second step that we're going to follow is set them equal to each other, which is why they're called the equal values method. We solve for x first, and then we plug it back in and solve for y so that we end up with an xy point. Let's color code here, x and y. Okay, example. First one is already in y equals mx plus b. The second one is not though. So we're going to take this and we're going to subtract the 4x over and convert this one into y equals negative 4x plus 26. Now that 26 that's right there is exactly the reason why we don't want to solve this one by graphing, because we would have a nasty y-intercept of 26. So I'm going to take this, negative 4x plus 26, and I'm going to set that equal to, let's see what color were my notes, purple. So set that equal to the other equation, which in this case is an x minus 4. Then we're going to solve for x first. So I like to get my x's positive. Let's plus 4x. I get 26 equals 5x minus 4 plus 4. Cancel, plus 4. And I get 30 equals 5x divided by 5. X equals 6. So I'm going to have a 6 up here for my answer in a blank, comma, blank solution. So then I need to plug that back in, and it doesn't really matter what equation that I plug it into. So I can plug a 6 in here, or I can plug a 6 in here, or I can even plug a 6 in here, and I should get the same answer, because remember, when we solve a system of equations, it's where they're equal. I think that this one looks the easiest, so I'm going to plug it in for that one. So we have y equals, I'm going to fill that in, minus 4, and plug in the 6. So 6 minus 4 is 2. So I have a y equals 2, and there's my answer. 6 comma 2 is where these two graphs or two lines would intersect on a graph. All right, so that's it for today, and tomorrow's notes will complete this note page for you. Have a good night.